All right. Greetings, boys and girls, and any families who are tuning into this video. This is meant to just be a basic overview tutorial of what we're going to be doing in class this Wednesday and Thursday. Okay. So we just finished our unit on proportionality. Okay. Proportional relationships on a graph are represented by lines that go through the origin, like this one, y equals x. It's a proportional relationship. It goes to the origin, and this one happens to have a rate of 1, right? And remember, we could figure that out, the rate, that is, by doing y divided by x. So finding a friendly point, which you could identify here maybe at 2, 2. Do y divided by x. 2 divided by 2 is 1. Let's say you chose this point up here at 4, 4. Well, 4 divided by 4 is still 1. So regardless of what friendly point you choose, y divided by x equals the rate k, which is 1 in this case. Now, the rate's not always 1. Sometimes it can be different, right? And we can also find the rate in a table format. Check this out. Here's the table format for y equals x here on the left side of the screen. And we learned in the last unit that when we do y divided by x, if it's consistent every time, that means the relationship is proportional. Well, check this out. If we do y divided by x every time, we're going to get 1. So we can find the rate that way as well, okay? So that's a little review of what we did the last week or so. Now, this week, in this next part of the unit, we're going to transition into transforming lines. So looking at lines that maybe go through the origin, but maybe don't. So we're going to look at 3 different elements of the line. We're going to look at the starting point of the line. That's the first thing. Usually it's 0 for proportional. It's always 0 for proportional, but we're going to look at some other starting points. So starting point, steepness is the second thing, and direction. We're going to look at those 3 elements of the graph, okay? So y equals x, that's called the parent function, because every other line equation or function is based off of that. It's based off of y equals x, the parent function. Any other line is some kind of derivation of the parent function. So let's compare y equals x to another equation, y equals 2x. Well, what happened here? Comparison between y equals x and y equals 2x is what? It looks like the y equals 2x line is steeper. And again, that shouldn't be that new either, because we learned about how the rate affects the steepness in the last part of the unit. Remember, the higher the rate, the steeper the line, right? The higher the rate, the steeper the line. So y equals 2x would be steeper. What if I said y equals 1/2 x? Well, that's less steep, right? Because 1/2 is less than 1. And the parent function has a rate of 1. 1/2 is less than that, so it's less steep, okay? All right, so we can see there that if the rate is greater than 1, it's steeper than the parent function. If it's less than 1, like a fraction, it is less steep than the parent function. Let's see how the graph changes if I tack on something after the x. So I'm going to keep just x still. So I'm going to keep that the same as the parent function. But this time I'm going to go plus 4. What happened here? It looks like it's the exact same line, but it was just shifted up 4 units, right? In geometric terms, that's called a translation. And we learned about that in the beginning of the school year. It shifted up 4 units, okay? Now, the steepness remained the same. In fact, these lines are completely parallel. They'll never touch. The only thing that changed is the starting point, right? For y equals x, the starting point is 0, whereas the starting point for x equals 4, that starting point is 0, 4, right? It starts at 4 rather than 0, and that's connected to the plus 4 in the equation, okay? Last thing, let's compare y equals x to y equals negative x. Interesting, okay. Y equals negative x, it looks like they make a perfect x. It's perfectly symmetrical along the y-axis. It looks like the steepness is exactly the same for both of these lines. The only difference is one's going uphill, the parent function is going uphill, and y equals negative x is going downhill from left to right. It's decreasing from left to right. So when you put a negative sign in front of the x, that makes it change direction, okay? Now, what if I said y equals negative 2x? Well, now, not only did it change direction, but it's also steeper, right? It's also steeper going downhill. So that y equals negative 2x, it's going steeply downhill because of the negative 2, right? Well, what if I made it negative 2x minus 1? Well, that just shifted it down 1 unit, right? So here's y equals negative 2x, and then when I add the minus 1, it just shifts it down 1, okay? Do you see how we can change our equation and how that affects the graph. Okay, so hopefully that's a nice little overview. That should help put you in good position to complete the activity, which is available on Schoology. You'll want to print it off, or you can open it in Kami and go through the simulation in Desmos. So you'll want to have Desmos open while you go through the activity. Okay, thanks for watching, and please let me know if you have any questions. Okay, thanks everybody. Be well.